Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run conjoint analysis in SPSS. Conjoint analysis is a statistical technique used in market research to understand consumer preferences and the value they place on different attributes of a product or service. It helps in determining how different features and attributes of a product influence consumer choices and purchase decisions. Applications of conjoint analysis. We start with the product development. Companies use conjoint analysis to design new products by understanding which features, that is, color, size, design, are most valued by consumers. For instance, a smartphone manufacturer might use it to decide on the optimal combination of screen size, battery life, and camera quality to get more sales. Pricing strategies. Service providers like airlines or hotels use it to find the best pricing structure for different service tiers or packages. Market segmentation. Pharmaceutical companies might segment patients based on their preferences for drug attributes such as efficacy, side effects, and cost. Service design. Banks and insurance companies apply to design product offerings such as loan packages or insurance plans based on customer needs and preferences. Customer experience optimizations. Businesses use it to enhance customer experience by identifying and improving aspects of the service environment, menu items, or store layout that are most important to their customers. Policy and regulations. Government agencies use it to understand public preferences for different policy options or public services, helping to design policies that better meets the needs of the population. Conjoint uses a full profile, also known as a full concept approach, where respondents rank, order, or score a set of profiles or cards according to the preference. Each profile describes a complete product or service and consists of different combinations of factor labels for all factors attributes of interest. This I will explain in next slide. Orthogonality. Orthogonality in conjoint analysis refers to the design property where the labels of different attributes are combined in such a way that they are statistically independent of each other. This means that the labels of one attribute do not affect or correlate with the labels of another attribute in the experimental design. Orthogonality ensures that the effect of each attribute label on the outcome can be estimated independently from the effects of other attributes. Now in the next slide, I will explain the concept of full profile and orthogonality. For example, suppose that you want to book an airline flight. You have the choice of sitting in a cramped seat or a spacious seat, keeping all other things constant. If this were the only consideration, your choice would be clear. Definitely you would have gone for the spacious seat. Now there is another decision which you have to take. Suppose you have a choice of ticket prices, $225 or $800. On price alone, taking nothing else into the consideration, the lower price would be preferable. Finally, suppose you can take either a direct flight which takes 2 hours or a flight with one layover which takes 5 hours. Most people would choose the direct flight. Now there can be the combinations such as cramped seat, spacious seat, $225, $800. 2 hours journey or a 5 hours journey. So considering this, how many profiles can come into the existence? Let's understand. Labels are two: cramped seat or spacious seat, 225 or 800, and 2 hours, 5 hours. Labels are two. How many attributes are there? One, that is seat; two, which is price; three, which is time. So 2 labels and 3 attributes. So 2 raised to 3, 8 profiles, 8 products comes into the existence. So cramped. The comfort is cramped. Price $225. Duration 2 hours. Second, cramped $225, 5 hours. Third, cramped $800, 2 hours. Fourth, cramped $800, 5 hours. Fifth, spacious $225, 2 hours. Sixth, spacious $225, 5 hours. 7. Spacious $800, 2 hours. 8. Spacious $800 and 5 hours. Now, just see the profile 5 and profile 4. Crammed seat. Price $800. Duration 5 hours. So this is the least preferred profile designed by the customer. Now see the fifth one, spacious, $225, 2 hours, most preferred. So this profile is most preferred. Given the above alternatives, product 4 is probably the least preferred, while product 5 is probably the most preferred. The preferences of respondents for other product offerings are implicitly determined by what is important to the respondent. The size of the sample in conjoint studies varies greatly. In one report, the author states that the sample size in the commercial conjoint studies usually ranges from 100 to 1000, with 300 to 550 the most typical range. In another study, it is found that the smaller sample sizes less than 100 are typical. As always, the sample size should be large enough to ensure reliability. Now, how to record the preference? The conjoint procedure allows for 3 methods of data recording. In the first method, subjects are asked to assign a preference score to each profile. Now, what is this profile? This 1, 2, 3. This is profile. The unique design. As each design is unique, it is also known as a orthogonality. See, this is the concept which we were discussing. Orthogonality ensures that the effect of each attribute level on the outcome can be estimated independently from the effects of other attributes. So in the first method, subjects are asked to assign a preference score to each profile. This type of method is typical when the Likert scale is used or when the subjects are asked to assign a number from 1 to 100 to indicate preference. In the second method, subjects are asked to assign a rank to each profile ranging from 1 to the total number of profiles. Okay, let's go back. 8 profiles are there. The most preferred, we start with the fourth one, so we will give the rank 1. And the least preferred, cramped $800, 5 hours is a least preferred, so this is least preferred, and the profile 5 is most preferred. So we will give the first rank to the fifth, and we will go on giving the rank, and the last rank will be for this fourth profile. So possibly it will get the 8th rank. 8 profile, 8 rank. So in the second method, subjects are asked to assign a rank to each profile ranging from 1 to the total number of the profiles. In the third method, subjects are asked to sort the profiles in terms of preference. With the last method, the researcher records the profile numbers in the order given by each subject. Analysis of the data is done with the conjoint procedure available. So it is available in SPSS only through command syntax and results in a utility score called part worth for each factor level. These utility scores, analogous to regression coefficients, provide a quantitative measure of the preference for each factor level, with large values corresponding to the greater preference. Part worths are experienced in a common unit, allowing them to be added together to give the total utility or overall preference for any combination of the factor levels. The part worths then constitute a model for predicting the preference of any product profile, including profiles referred to as a simulation cases that were not actually presented in the experiment. So let's understand this part worth utilities. So the company offers the color in the car in two variants, black and red. So this is the variant according to the color. Now according to the fuel, the black color car available in petrol, black color car available in diesel, red color car petrol, red color car diesel. So this is the variant, the fuel variant. The next is the transmission variant. So black color car petrol automatic, black color car petrol manual, black color car diesel automatic, black color car diesel manual, red color petrol automatic, red color petrol manual, red color diesel automatic, red color diesel manual. So 8 designs are available, 8 profiles are available. So this is known as a orthogonality. Each design is unique. So now we can ask to the customer the most preferred profile, and we will give the number 1, and the least profile. So we will give the number 8. So the number of models of the car is equal to levels raised to attribute. How many levels are there? See, for each attribute, level are 2, black, red, 2 level, petrol, diesel, 2 level for fuel. For transmission, automatic, manual, level is only 2. So levels 2, attribute 3. So 2 raised to 3. 8 designs are available, 8 models are available, 8 profiles are available. 1, 2, 3, 4, 5, 6, 7, 8. So 2 raised to 1 is 2. So if the attribute is 1, 1 and 2. Now there are 2 attributes. So 4, 1, 2, 3, 4, 3 attributes. So 8 profiles are available. Now we will do the dummy coding in this. By converting attributes into binary value, the resulting coefficients, part worth utilities are easier to interpret. In conjoint analysis, converting design levels into the binary values like 1 and -1 is a tactic used to simplify the statistical analysis and estimations of part worth utilities. This process is known as a dummy coding or effect coding. Using binary values simplifies the mathematical calculations involved in estimating part worth utilities. In many statistical techniques, including regression analysis, using 1 and -1 or 0 and 1 instead of categorical values like low and high makes the mathematical operations more straightforward. Now let's see the profile. Black, petrol, automatic. So the color, fuel, transmission. So first 4 are black and then red. Next is petrol, diesel, and in the last transmission is automatic, manual. Now we will convert this into the dummy coding. Just see on the screen. So 1, 1, 1, 1. So black color 1, red color -1, -1, -1, -1. Fuel 1, 1, -1, -1, 1, 1, -1, -1. Transmission 1, -1, 1, -1. So you can see there is no repetition of any profile here. This is the combination, their codes and the unique design. So 8 profiles are available. 1, 2, 3, 4, 5, 6, 7, 8. This we will represent in cube. X level represents transmission. The x-axis represents transmission. Y represents the fuel. And the Z represents the color. Now let's understand this. Design 1. The profile 1. Okay. So it is having the color is 1 means the black color. See, I have just used the red color to show you the design. Okay. So color 1, fuel 1, transmission 1. I have copied this directly on this page. Okay, so we start with 1. Now the second, transmission. So color and fuel as it is, transmission is -1, 3, 1, -1, 1, 4, 1, -1, -1, 5, -1, 1, 1, 6, -1, 1, -1, 7, -1, -1, 1, and the last is 8, -1, -1, -1. In typical conjoint analysis model, the utility function for a product profile I can be expressed as UI is equal to beta 0 plus beta color, color I plus beta fuel into fuel I plus beta transmission into transmission I, and the error term. UI is the utility of profile I, beta 0 is a baseline utility or constant term, beta color represents the path worth utility for the color attribute. That is how much importance is for the color we will get from beta color. Beta fuel represents the path worth utility for the fuel type attribute. Beta transmission. Beta transmission represents the path worth utility for the transmission attribute. Now, color I, fuel I, and transmission I are the binary indicators or the coded value, 1 or -1. So if the color is red, let's understand this. Yeah, this one. So if the color is black, the code is 1. If the color is red, -1. If the fuel is petrol, the code is 1, and diesel -1. In transmission, automatic, code is 1, manual -1. Okay. So color, fuel, and transmission are the binary indicators or coded value for the levels of the respective attributes for profile I. Epsilon I is the error term associated with profile I, capturing the random variation in preferences not explained by the observed attributes. So the part worth utilities which remain unexplained is captured by epsilon I. Now we want to see the main effect of the transmission. So we will pick up the transmission coded -1 only, -1, -1, -1, -1, and then we will pick up the profiles which are having only 1, 1, 1, 1, and 1. So the profiles with only -1 in transmission, and profile with only 1 in transmission. Okay, now what we will do? We will take the summation of the ranks. So these are the ranks which are given by the customers, the most preferred and the least preferred. So 2, 4, 6, 8. Transmission is -1, -1, -1, -1, and the ranks are 7, 3, 5, and 1. So let's take the summation of it. 7 plus 3, 10 plus 5, 15 plus 1, 16. Okay, now we will take the summation of 1, 1, 1, 1. So 8 plus 4 plus 6 plus 2. So 16 minus 20. And the main effect of the transmission is 1 by 4. 16. 1 by 4, why? 1, 2, 3, 4. 1 by 4. 16 minus 20 divided by 2. Because two different types of transmission are there. So here 1, 3, 5, and 7, and here 2, 4, 6, and 8. 2, 4, 6, 8. That's the reason we divide by 2. Okay, so how much we get? The main effect, 1 by 4, 16 minus 20 divided by 2 is minus 0.5. Now we want to take the effect of fuel. So just focus here. We will take all those profiles where only 1 is there in fuel, 1, 1, 1, 1, and take its summation. Then we will take the summation of minus 1 minus summation of the rank of the profiles having minus 1, minus 1, minus 1, and minus 1. Which are these designs? 1, 2, 5, and 6. 1, 2, 5, 6. So next is 3, 4, 7, 8. So we have taken minus 1, minus 1, minus 1. So this is the main effect of fuel. So take the addition. Take the addition of 8 plus 7 plus 6 plus 5, and then take the addition of 4 plus 3 plus 2 plus 1. So 1 by 4, 10 minus 26 divided by 2 is minus 2. Okay, let's understand these things again. Why we are doing this way? See, in when we have represented this profile on the cube, x-axis was transmission. So the change in transmission happened on 2, 4, 6, and 8. 1, 3, 5, and 7. The transmission was same, but in this set of profiles, the transmission changed because transmission is on x-axis. In case of fuel, 1, 2, 5, and 6. These profiles are having same fuel. 3, 4, 7, 8. The fuel change. So if I want to measure the effect of fuel, so I'll take the two sets of different profiles. So fuel is on Y. Now I want to capture the effect of color. What will be the design? Can you guess? 1, 2, 3, 4. One set. Second is 5, 6, 7, 8. Okay, let's go back to this. So we have seen the effect of transmission, fuel. Now let's see the effect of color. So all those profiles which are having minus 1, 1, 2, 3, 4. Let me color just a minute. So 1, 2, 3, 4, color 1, 1, 1, and the ranks. Then we will take the next profiles 5, 6, 7, 8. Here color minus 1, minus 1, minus 1, minus 1, and their summation. So what will be the summation of 8 plus 7 plus 4 plus 3, and then the summation of 6 plus 5 plus 2 plus 1. So 1 by 4 into bracket 14 minus 22 divided by 2 is minus 1. Now we want to calculate the relative weights. So beta transmission, beta fuel, beta color. So we got this estimates plus or minus 0.5, plus or minus 2, plus or minus 1. From where we got it? Here is it. Minus 1, fuel minus 2, and transmission minus 0.5. So plus or minus 0.5, the range will be 1, plus or minus 2, 4, plus or minus 1, 2. So 1, 4, 2, take the total 7. So what is the importance of transmission? 1 divided by 7, 14%. What is the importance of fuel? 4 divided by 7, 57%. Color, 2 divided by 7, 29%. So the customer gives more preference to the fuel, that is mileage, in comparison to the transmission and color. Now, how to run conjoint analysis in SPSS? Let's understand. SPSS does not have any graphic user interface for running conjoint. So we will have to activate its syntax first. So you go in File, Open, Syntax. Now in this C drive, Program Files, IBM, SPSS, Statistics, 25, Samples, English, and here is a syntax for conjoint analysis. Click on it, open. So here is a syntax. Now it demands the conjoint plan and the data. So let's see the plan as well as data. Now SPSS is having a default data set. So we will go in C drive, program files, IBM, SPSS, statistics. In this, we'll go in sample and English. And in this, we are having two files, carpet plan and carpet preference. In my previous video, I've explained how to create plans. So let me open this carpet plan, open with IBM SPSS. Now see, this file consists of package. Three types of package are there: A, B, and C. Brand of the carpet, Glory, K2R, and Bezel. The prices are 1.19, 1.39, and 1.59. Do you require seal? Yes or no. Money back guarantee? Yes or no. And the status and card. So this is one file. This is the plan. And this is the preference. Just a minute. I'll open it with. So 10 customers and their preference. Okay. So in total, there were 24 profiles. So you will see the first customer, the preference 1, then 2, 3, all will be available, and the last one is 24. Similarly for customer 2, customer 3. Okay. Now we want to analyze this. So make it sure that you close it. And now you go in the syntax. We will have to copy and paste the file specification of the plan and the data. So I will go in the Windows Explorer, carpet plan, right click on it, and here it is, copy as path. Now go in the syntax again, press Ctrl V. So remove the double inverted commas. It should be having only single inverted commas. Remove it. So this is the plan, the source of the plan. Now the data. So again, I will go in Windows Explorer, carpet preference, right click on it, copy as path, and paste it here, file specification, Control V, remove the double inverted commas, and press this play button. You got the result. So model description, overall statistics, importance values, coefficient, correlations, number of reversals. I have copied all this on my slide, and let's write the interpretation one by one. We start with utilities. Package ABC, its utility estimates, brand, its utility estimates, price, seal, and money. In the given conjoint analysis data, the utility estimates represents the relative value consumer place on different levels of product attributes with associated standard errors indicating the precision of these estimates. For the package attribute, package A asterisk has a utility of minus 2.233, this one, with a standard error of 0.192, suggesting it is a less preferred compared to other packages. Package B has a positive utility of 1.867, indicating a high preference. while package C has a utility of 0.367. So this is 1.867, this is 0.367, placing it in between. Okay. Regarding brand, so K2R is positive and Glory is negative. The utility for K2R is 0.367, showing a slight preference for this brand, whereas Glory has a negative utility of minus 0.350, indicating the lower preference. And Bissell has near zero utility of minus 0.017, suggesting it is neither preferred nor disliked significantly. Price has substantially negative impact on utility because all of them are negative, with a higher prices decreasing overall preference. For example, the utility for a price of $1.19 is minus 6.59, while it drops to minus 8.811. Here, the minus is here. Just a minute, let me change it. At $1.59, reflecting a significant reduction in attractiveness as price increases. The seal attribute shows a clear preference for products with a seal. So yes, 4, no, 2, with a utility for 4 compared to 2 for products without a seal. This indicates that the consumers value the presence of seal. Similarly, the money attribute also shows a preference for products with money refund guarantee. So with a utility of 2.5 versus 1.240 for products without money refund guarantee. I will write the utility equation using this estimate. The overall utility U for product profile can be calculated as U is equal to constant plus utility package plus utility brand plus utility price plus utility seed plus utility money. Package, let's take one example. Package is B asterisk, brand is K2R, price is $1.39, seal is yes, money is no. So what will be the value of the utility? Just we will pick up the utility estimates from here one by one, and then we will take the summation, which is 12.750. This is the utility. Importance values. This I will get it from here. Importance value. Package. Its value is 35.635 with an importance value of 35.635. The package attribute is the most significant factor influencing consumer choice among the attributes listed. This suggests that the consumer places a high level of importance on the type of package when making purchasing decision. Price. The importance value for price is 29.410, indicating that while price is crucial, it is slightly less important than the package attribute. Price remains a key determinant for consumer preference but is secondary to the package in this context. Brand. With an importance value of the brand 14.911, brand plays a moderate role in consumer decision making. It is less influential than package and price but still holds a notable impact on preference. Seal. The seal attribute has an importance value of 11.172. This suggests that while the presence or absence of seal affects consumer choices, it is less important compared to package, price, and brand. Money back guarantee. The attribute related to money has the lowest importance value of 8.872. This indicates that it is the least impact on consumer preferences among the attributes considered. Coefficients. The negative coefficient of price. This is generated here. The negative coefficient that is minus 5.542 indicates that as the price of the product increases, the utility decreases significantly. A coefficient of minus 5.542 suggests that the higher prices are strongly disliked by consumer, reflecting a high sensitivity to price changes. Seal. This positive coefficient means that the presence of seal adds value to the product. A coefficient of 2 implies that the consumers have a favorable view of products with a seal and they are willing to assign a higher utility to such products compared to those without a seal. Money back guarantee similar. This positive coefficient indicates that the presence of money, the money back guarantee, adds to the product's utility. A coefficient of 1.250 shows that the consumer prefer products with money included and assign additional utility to these products. High correlations. So here is it, high correlation. So the values of Pearson R is 0.982 and Kendall's tau for holdout is 0.667. Let's write the interpretation. The high Pearson R 0.982 and Kendall's tau 0.8892 value indicates that the model's estimates are highly reliable and closely match the actual consumer preferences, demonstrating a strong fit of the model to the data. Holdout samples. The moderate correlation for holdouts, this one 0.667, suggests that while the model performs well on the main data set, there may be some variability in its predictions for the data not used during model training. That is, if the another data set is given, there can be some variations. Reversals. Reversals in conjoint analysis refers to a situation where the predicted preferences or rankings derived from the conjoint model do not align with the actual observed choices or ranks. In a simple language, we can say the cases which don't follow this model, the outliers which don't follow this model. These discrepancies can occur due to the various reasons, and understanding them is crucial for improving the accuracy of the model. Let us see that how many such cases are there in which the sign reversal, the number of reversals has taken place. Price 3, money 2, seal 2, brand 0, package 0. Now let's write the interpretation of it. For the price attribute, there are 3 reversals, indicating that the discrepancies between the predicted and actual preference are most common for this attribute. The money attribute has 2 reversals, suggesting that there are also notable inconsistencies in predicted preferences for money-related features. Similarly, the seal attribute experiences 2 reversals, reflective some degree of misalignment in the predictions related to the presence or absence of a seal. In contrast, the brand and package attributes do not have any reversals, implying that the model's predictions for these attributes align well with the observed preferences. Examining individual subjects, subject 1 and subject 2 each exhibit 1 reversal. How many subjects are there? 10. Let's see the data. So 10 cases are there. Okay. So subject 1 has 1 reversal, subject 2, 2 reversal, subject 9, 1 reversal, subject 10, 2 reversal. Examining individual subjects, subject 1 and 2 each exhibit 1 reversal. So let me change this. Subject 1 is having 1 reversal and subject 2 is having 2 reversal. While the subject 6 and subject 9, 6 and 9 also has 1 reversal each. Subjects 3, 4, 5, 7 and 8 have no reversals, indicating that for the subjects the model's predictions closely match their actual preferences, or in other words, the model fits the data well. Subject 10 has 2 reversals, similarly to the number observed for price and money attributes. So this was all about running conjoint analysis in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I uploaded videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.